In this video, I'm going to talk about 8-8 variables and expressions. This is very similar to what we did in 8-1. So you'll be given a phrase and you will need to turn it into an algebraic expression. If you still have your chart from 8-1, that would be a good tool to use. However, since this is kind of the second time we are doing this, if you feel confident, I would recommend trying it without using your chart this time. Here we go. Okay, so if you remember back to 8-1, we were given phrases like this and we turned it into an algebraic expression. An algebraic expression usually has a letter, a variable, a number of some sort, and an operation, adding, subtracting, multiplying, or dividing. So what's going to be a little bit different in this lesson is we are going to focus more on kind of real world applications of these problems. So rather than 5 more than A, we're going to be using some more realistic situations. In this case, we're talking about the cost of a shirt or something like that. So this one says 4 times the cost of one shirt. So here you need to come up with your own variable. The unknown thing is how much one shirt costs. So if you are ever unsure, a good variable to use is x or n. Mathematicians use those a lot. Or you can look at kind of your label, what you're talking about, and see if you can come up with a variable from that. So since we're talking about shirts, I'm going to go ahead and use the variable s. And my problem says that I have 4 times the cost of one shirt. So one shirt would cost this much, s, whatever that is, and I have 4 times that amount. So there's a few ways I could write that. I'm going to go ahead and circle my number words and underline anything that tells me what operation to do. So I know I'm doing times, multiplication, and it's 4 times the cost of one shirt. I could write 4 times s or 4s. In this problem, we have a number of crayons divided into, and this should say 6, not B, 6 baskets. Okay, so I have some number of crayons, I'm not sure how many, and it says divided into, I'm going to underline those words that tell me what operation I'm going to do and circle any numbers. So I have 6 and some number of crayons. I could use something like X to represent that. I'm going to go ahead and use C for crayons. And I'm taking my total unknown number of crayons, C, and I'm dividing it up into 6 different baskets. Now what's tricky about this is normally when we have the phrase divided into, we talked in 8-1 that the order of the number and the variable switches. So first we see C, crayons, and then 6. So normally that would mean with divided into, we would switch 6 and C and have it like this. But we need to go back and think. Things can be a little bit different in these kind of word problems in 8-8. So if I go back and think about that, that would be that I have 6 things, and I'm splitting them up into C groups, whatever that is. But that's not quite the case here. What we're actually doing is we're taking our crayons, however many I have, and I'm splitting them up into 6 baskets. So this would be the correct algebraic expression. One thing that you can do if you're unsure if you need to flip it or not is plug in a number for whatever your unknown is. So it says a number of crayons. I'm going to pretend I had 36 crayons. And if I was taking 36 crayons and splitting them up into 6 baskets, can kind of draw myself a little visual picture, I would have 6 in each. So C would be 36 divided by 6 would indeed give me 6. If I had tried flipping it and doing 6 divided by C, well, 6 divided by 36, that would not make sense, nor would it give me the answer of 6. So plugging in a real number can help you understand and check your algebraic expression a little bit more. In the next few problems, the word problems are going to get a little bit longer and a bit more intricate. So this one says, if H represents the amount of time that Tom spends on homework each day of the week, write an expression to show how long Tom will spend on homework in 1 full week. How long will he spend in 2 full weeks? So H is how much he spends on homework in 1 day. Okay, so let's say, that's Monday, and then Tuesday he would spend H, and Wednesday he would spend H amount of time. If I want to know how much he spends in 1 week, 1 full week, that's important there. So that means every day of the week, I need to think, well, how many days are in 1 week? 7. And the next question, it's kind of a 2-part question here, is how long would he spend if it were 2 full weeks? So 2 full weeks has 14 days. Now, there really isn't a math word that tells us what operation to do, and that's what makes this one a little bit tricky. We need to go ahead and think if we had an actual number of or amount of time that he spent on homework. Let's say he spent 1 hour on homework. Okay, that was H. Let's pretend. If I wanted to know how much he spent in 1 full week, I would do the number of hours that he spent in 1 day times 7, the amount of days in the week. So I just plugged in this 1, okay, for H. So really what I had was H times 7, or I could also write that as just 7H. Okay, so same thing with 2 full weeks, but instead of 7, it would be 14. So I would do H times 14. I could also write that as 14H. So this one just required a little bit more thought on our part, but plugging in a number can really help you make sense of a problem like this. Here's another one. Sarah's friend pays for her to go to the movies, but she needs to pay her back. She gives her $5 at school the next day, but still owes her more money. If M represents the number or the amount that Sarah owes her friend, write an expression to show how much Sarah owes after she's paid back that part of the money that she owes. Wow, that was a long problem. We need to go back and kind of pull out the important parts, okay? We need to go back, and I see something about $5 and M. So M is the amount that Sarah owes her friend. So she owes her back this much money. But she already gave her $5. I'm going to draw myself a little bit of a picture here. If this is the total amount that she owes, Sarah gave her $5 one day, but she still owes back this shaded in part, if that's all M. So if she owes back M, this whole thing, but she paid back $5 already, I can take away the $5 that she already paid, and that will tell me how much she still owes left. Here's another one. Nathan's buying a new car, and he has to put down a $100 deposit on the car. A deposit is an amount of money that you put down to kind of reserve the car, or it's money that you pay up front, and then you'll pay the rest back later. So if P represents the full price of the car, write an expression to show how much he still owes after he paid that deposit. So if he's owed all this money, P, for the car, he paid a little chunk of it, $100, right, because cars are expensive. So he still owes some money there. So what is left, think back to when we did bar pictures for adding and subtracting. He owes this much in all, but he can take away the part that he already paid. So even though it doesn't tell us any keyword that usually signifies subtraction here, we can still kind of think it through and come up with that on our own. I want you to try this one on your own and bring the expression with you to class tomorrow for points. Okay, so you need to come up with the variable on your own and write the expression to show that if I bought Murphy 7 bones and after a day at the doggy park he digs up some more, how many does he have in all? Good luck!